Hello students, welcome to Accounting 2302, Managerial Accounting. This is Dr. Mercado, and in today's lecture we are going to be covering content from Chapter 26, which deals with capital investment analysis. A friendly reminder to please make sure to read the chapter before you attempt any of your assignments. And just like I work out my problems, I find the problem and then I identify the section of the ebook that applies to that problem. I read over it, I look at the examples. That is how you should be tackling each of your problems. That way you can identify the area from the ebook, locate the examples, and be able to use that information to help you complete your homework. Okay, so I just want to encourage all of you to please make sure to read before you begin any of your work for the week. Okay, now the problem that we're going to be covering in this particular lecture is going to be on your final exam. That is why I've selected it to cover it in detail with you. It covers the average rate of return method, the net present value method, and the analysis for a service company. Okay, so the problem reads as follows. The Capital Investment Committee of Iguana Incorporated is considering two capital investments. The estimated operating income and net cash flows from each investment are as follows. So we're looking at a 5-year investment. So we have the robotic assembler and the warehouse. We've got the operating income and the net cash flow for each of the projects that we're looking at. Now, if you look at the total here, regardless if we select the robotic assembler or the warehouse, my operating income for both projects is $105,000 and my net cash flow is $255,000. The only thing that changes is the order and where the operating income is coming on. If we look at the robotic assembler, the majority of the income is being obtained in the first years of operations. For the warehouse, it is steady at $21,000 per year. So this provides us with a uniform income, while the robotic assembler has higher incomes in the first years of operation and the income dwindles down as the years pass by. Okay, the net cash flow is also from greatest to least on the robotic assembler. My net cash flow is going to be greater the first couple of years, versus my net cash flow for the warehouse is consistent at $51,000 per year. But at the end of the day, regardless of the project that we select, they will both yield the same amount of operating income and the same amount of net cash flows. Now, having that data, now we have to analyze the information. Okay, each project requires an investment of $150,000. Straight line depreciation is being used and no residual value is expected. The committee has selected a rate of 12% for purposes of the net present value analysis. Instructions. We are to A, compute the average rate of return for each investment. Okay, so on your ebook, we do have the information on the average rate of return. Before we go that route, let's quickly highlight what this chapter or a specific section of the chapter covers. So there's 4 methods being explained in this chapter for dealing with capital investment analysis. We have 2 methods that do not use present values. We have the average rate of return method and the cash payback period. In this problem, we are going to be using the average rate of return method, and we are going to be comparing that method to my net present value method. So we're going to have one that uses present values and one that does not use present values to evaluate the information and then make a decision. Okay, so the methods that use present values are the net present value method and the internal rate of return method. Okay, now the 2 methods that use the present values consider the time value of money. Okay, the time value of money concept recognizes that $1 today is worth more than $1 tomorrow because today's dollar can earn interest. So when we're dealing with the calculations for net present value, that factor is going to be very important. Okay, the time the money is received, the timing of when it's received is critical to be able to figure out the net present value for that specific project. Now, the first thing that we are going to be tackling is the average rate of return. If you go to your ebook, you will find a section and there's just more information. I just copied a piece of it. So please go back and refer to section 26.01A that talks about the average rate of return. So the average rate of return, sometimes called the accounting rate of return, measures the average income as a percent of the average investment. Okay, the average rate of return is computed as follows. So here we have the formula that we're going to be applying. Average annual income over the average investment. Okay, now if you notice, we have average investment as a denominator. The numerator is the average of the annual income expected to be earned from the investment over its life after deducting depreciation. The denominator is the average investment, that's the book value, over the life of the investment. Assuming straight line depreciation, the average investment is computed as follows. So for us to be able to figure out our denominator, we have to apply a separate formula. The average investment equals your initial cost plus your residual value divided by 2. So we're going to be using the combination of these two formulas because we need to calculate the average investment. We plug that number into the average rate of return to be able to calculate our average rate of return, which is what they are asking us in requirement 1. Okay, so I've copied the formula, average annual income over average investment. That is coming from here. Okay, now before I begin plugging in numbers, I am going to calculate my average investment because I need that number to plug it into my formula. So I'm going to go ahead and I'm going to calculate my average investment. Okay, now for your average investment, we are going to have the cost. Okay, how much are we spending on this project? And it says each project requires an investment of $150,000. Now, because both projects give you the same operating income and net cash flows, both projects have an initial investment of $150,000. We only basically have to do this calculation once because the numbers are the same for both projects. So, my average annual income, we're calculating the initial cost first. Okay, so we're going to calculate the average investment. My initial cost, according to the problem, my cost is $150,000. Okay, I'm going to add my residual value, and according to the problem, we have a residual value of no residual value. So my residual value is 0. Okay. And then I am going to divide by 2. Okay. So that is going to give me, okay, so 150,000 plus 0 equals 150,000 divided by 2. My average investment is $75,000. Now I'm going to use this number and be able to plug it into the formula to calculate the average rate of return. For the average rate of return, we're going to have our average annual income. Okay. So my average annual income, if we look at the problem, your average annual income is $105,000 for both projects. $105,000 is your income, okay, for each project. Sorry about that, $105,000. And I'm going to divide that number by my average investment. I've already calculated my average investment down here for $75,000. Okay, so let's see what that gives us. Okay, so we're going to get our calculator. We're going to get our average annual income of $105,000 divided by my average investment of $75,000. That's going to give me, okay, we are missing one thing. Okay, to calculate the average annual income, this is my income for the 5 years. I'm sorry. That's the income for the entire 5 years. We want to get an average per year. Okay, so I need to divide that number by the 5 years so I can get an average. Okay, I was missing that component. Let me put a comma here. 105,000 right there. Okay, so I am going to get 105,000 for the entire 5-year span. Okay, that's the total income for the 5 years. I want to get an average annual income. That's average per year. So I'm going to divide the 105,000 by 5 years, and then I'm going to divide by the 75,000. So then that would give me, let's see the calculator, 105,000 divided by 5 years. That's going to give me 21,000. And then I'm going to divide that by 75,000, which is my average investment. So that's going to give me 0.28. If you want to convert that to a percentage, you multiply it by 100 and it gives you 28%. Okay. So my average rate of return for either project, because both projects are going to give me 105,000 in operating income, I divide my total income for the 5 years by the 5 years to get the average annual income, and then divide by my average investment. The average investment is calculated down here. Your initial cost plus your residual value divided by 2. That came up to 75,000. We plug that 75,000 into the formula over here, and then we get a 28% average rate of return. Okay, so both of the projects give me a 20% average rate of return. Okay, so that is the calculation for A. The average rate of return for each investment is 28%. Okay, so far doing the average rate of return analysis, both projects stand at the same position, 28%. Okay. Now requirement B, the net present value for each investment. Okay, we're going to calculate the net present value for each investment. It says use the present value table appearing in Exhibit 2, which I've copied down here for this chapter. Round present values to the nearest dollar. Okay, so we're going to calculate the present value for each of the years. Okay, because they do change. Okay, if you see, my net cash flows and my operating income vary by year, by project. At the end of the day, the totals are the same, but the flow of the money, of the income coming in, or the net cash flow is affected by the timing of when this money is being received. Okay, so they're asking us for, they've given us here the rate of 12%. Okay, so when we look at our partial present value table, we're going to be focusing on the 12% table. Okay, so the table is provided to us. We're going to be focusing on the 12% section. Okay, that section right there. Okay, now we're going to look at years 1 through 5. And we have the data here, years 1 through 5. So we're going to go ahead and we're going to get the present value of $1 at a compound of 12%. Okay, so the present value for year 1 is 0.893. Okay, I'm just going to bring those rates in. For year 2 is 0.797. For year 3 is 0.712. For year 4, we're doing 0.636. So all I'm doing is I'm picking up the information from the 12% column year by year. And then year 5 is 0.567. Okay. Now that we've got the present value of $1 at 12% each of the years. So if you see, the dollar is losing value as it's taking longer for us to collect it, basically, or earn that money. Okay. Now we're going to get the net cash flow. This is the money coming in, the cash flow coming in from each of the projects. Okay, so we're going to start off with the robotic assembler. Okay, for the robotic assembler, my net cash flow is going to be 65,000. My year 2 is going to be 55,000. Year 3, 50,000. Year 4, 45,000. And year 5, 40,000. So you see, my net cash flow is decreasing as the years pass by. I have the greatest amount of cash flow the first couple of years, and then that dwindles down. We're going to do the same thing for the warehouse. Now for the warehouse, every year is $51,000. So I'm going to get the same amount every year. Okay, I'm going to copy that over. Okay, so I'm just copying the information, just so you know, for reference. I am copying this information from the problem into my table, because now I'm going to have to do a little bit of math. Okay, So all we're doing is getting the net cash flow. We're gonna be multiplying the net cash flow from each of the projects with the present value of the dollar at the 12% rate that we identified from the Exhibit 2 table. Okay. So now what we're going to do is we're going to calculate the present value of net cash flow for the projects, okay? So we're going to go ahead and we're going to get the $65,000 for the robotic assembler times the present value rate, okay? That's going to give me $58,045 for year 1. I'm going to get the $55,000 times my rate for year 2. That's going to give me, let me just format all of this the same, $43,835. So you get the robotic assembler net cash flow times the rate, the present value rate for year 3. That gives me $35,600. And then we're going to do the robotic assembler year 4 net cash flow times my present value rate for year 4. That's going to give me $28,620. And then last but not least, I've got my robotic assembler for year 5 with net cash flows of $40,000 times my rate for year 5. That's going to give me $22,680. We're going to repeat the same step, but now we're going to pick up the information for the warehouse. Okay. Now for the warehouse, I've got my $51,000 times my rate. Okay. The net cash flow does not change. What changes is your rate. Okay. As the time passes by, that value of the dollar is worth less. Okay. So let's just, it's the same, the 51,000 times the rate for each of the years. Let me see, what did I do here? Equals the 51,000 times the 57. There we are. Okay. So we've got each of the calculations, and all we're doing is we're getting the net cash flows times the present value rate based on each of the years, and these rates are coming from the Exhibit 2. Okay, make sure that you do select the correct column depending on the rate given to you. Okay, now that we've got that, we're going to get our totals. Okay, so we're going to go ahead and we're going to get our totals. And because I am using Excel, it's just much easier. I don't have to use basically a calculator. I'm just going to run these formulas across so I can get my totals. So if you see here, my net cash flows for either project is $255,000. They both yield the same cash flow, but the present value of those net cash flows varies. Okay, the robotics assembler's present value of that net cash flow is greater than that of the warehouse. Okay, now we're going to deduct the amount to be invested. Okay, and we are investing, according to the problem, we are investing $150,000 for each of the projects. That's the amount of the investment. So we're going to put the $150,000, and that is outflow of cash because we have to put that money into the business or the project. Okay, so we're going to deduct the $150,000 investment that we're going to have to do for each of the projects, and then that will give me the net present value of each of the project options. Okay, so I'm going to underline here, and then I'm going to add my total minus the amount invested, and that's going to give me the net present value of each of the projects. Okay, so the net present value of the robotic assembler is $38,780. The present value of the warehouse is $33,855. Okay, so let me double underline it. There we go. So that is the calculation of the net present value of our cash flows. Okay, of our estimated cash flows for each of the projects. Okay, so that is the present value. So the robotic assembler yields a higher present value than the warehouse. Okay, now that is requirement 2. The actual calculation, and they're very simple. You just have to get the rates from the table and multiply it against your net cash flows for each of the projects. to give you your present value of the net cash flows, and then you can evaluate. Make sure you deduct your initial investment, and that will yield the net present value. Now, requirement 3. Prepare a brief report for the Capital Investment Committee advising it on the relative merits of the two investments. Okay? So, the report to the Capital Investment Committee can take many forms. It just depends how you all type it out or report the information. But at a minimum, each of the reports should point out that both projects offer the same average annual rate of return. The average annual rate of return for both projects is 28%. Okay? They both yield the same percentage because my operating income is the same for both projects. Both projects are for the same timeline, 5 years, and both projects have the same average investment. Okay? So they both yield 28%, so that's important to highlight. Okay? And then we can analyze the bottom section, okay, which is the calculation of your net present value for each investment. And if we look at the numbers, okay, although both projects exceed the selected rate established for the discounted cash flows, if we look at the information, the robotic assembler offers a larger net present value. If we look at that information, it's larger than the warehouse. The robotic assembler has a larger net present value. Why? Because larger cash flows occur earlier in the years, okay, compared to the warehouse. Thus, if we had to choose one of the two projects, both of them will yield the same operating income. They both have the same net cash flows. We would run with the robotic assembly, okay? That is a more attractive project because it yields a higher net present value. Okay. Now, in your book, it covers the net present value method, and basically the net present value method compares the amount to be invested with the present value of the net cash inflows. It is sometimes called the discounted cash flows method. The interest rate return used in the net present value analysis is the company's minimum desired rate of return. So according to our company, we wanted to get at least a 12% return in our investment, okay? Based on factors such as the purpose of the investment and the cost of obtaining the funds. If the present value of the cash inflows equals or exceeds the amount to be invested, the proposal is desirable. Now, the textbook provides you with a good analysis of the 4 main methods used when we are doing investment analysis. And if we look at the distribution, only 15% use the average rate of return. 53% use cash payback method. The largest usage is the net present value method, which is what we calculated here. This is the net present value of those cash flows. So we can figure out how much is the present value of what we're going to get in the future. Remember, the dollar today is worth more than the dollar tomorrow. Okay? And then 76% use the internal rate of return method. Okay? So the strongest methods used are the net present value method or the internal rate of return, both of which use the time value of money concept. Okay? So these are the calculations for the average annual rate of return for both projects, and then the second part, the net present value for each of the investments. Okay, and then of course, using the data, management has to decide which option yields the best. And in this case, the robotic assembler provides the highest present value of net cash flows. So we would go with that option if we needed to make a decision between the robotic assembler and the warehouse projects. Okay. Please, I highly encourage that as you progress, you always refer back to your ebook. Great information is being provided on your ebook. There's a lot of examples. The formulas are there so you can be able to apply it. Please make sure that you read carefully. As you're reading, you are understanding what is it that you're reading so you can be able to apply it to the respective homework problems. Okay, so that is it for this lecture. If you have any questions or concerns, please make sure to contact me through email, Blackboard, or Pronto. I am here to assist you in any way I can. Just make sure to please include a screenshot of the problem you're working on, your attempted step-by-step problem. That includes showing me your calculations. What is it you're doing? Don't just send me, well, I got 24%. How did you get 24%? I need to see the formula. How did you calculate that 24%? Okay, so make sure that you show me your work. Okay, if you're doing this section, okay, why are your numbers off? Well, I need to see how you're doing the calculation. Maybe you're using the incorrect present value information. Your rates are off. That is why all of your calculations are off. So I need you to please show me your work, because I am not a mind reader. So I need to be able to see it to be able to provide guidance and support to you. Okay? So that is it for me for this lecture. Until next time, have a wonderful and productive rest of your week. Bye-bye.